Welcome to the final section of our course, Objective 6, Automation and Programmability. This section accounts for 10% of your CCNA syllabus. In the past, network engineers managed devices one by one using a manual command line interface. Today, we use software and code to manage hundreds of devices simultaneously. This shift from manual configuration to automated systems increases speed, reduces human error, and allows the network to adapt to business needs in real time. 6.1. How automation impacts network management. Automation changes the daily life of a network engineer by moving away from repetitive tasks. Speed and efficiency. Instead of logging into 20 different switches to change a VLAN, an engineer can run a single script that updates all of them at once. Reduction in errors. Most network outages are caused by human typos. Automation ensures that configurations are consistent and tested before they are applied. Scaling. Automation allows a small team to manage thousands of devices. As a company grows, the workload does not have to increase at the same rate. Resource collection. Automation tools can quickly gather data and generate reports on network health, which would take hours to do manually. 6.2. Traditional networks versus controller-based networking. To understand modern networking, we must compare the old way with the new way. Traditional networks. In a traditional setup, each device is smart and makes its own decisions. This is called a distributed control plane. If you want to change a policy, you must touch every device individually. Controller-based networking. This uses a centralized brain called a controller. The engineer tells the controller what they want to happen, and the controller pushes those instructions out to all the switches and routers. This provides a single point of management for the entire network. 6.3. Controller-based software-defined architecture. Software-defined networking, or SDN, uses a specific structure to organize how data moves. Underlay. This is the physical infrastructure. It includes the actual cables, switches, and routers that sit in the equipment rack. Overlay. This is a virtual network that runs on top of the physical underlay. It allows us to create tunnels and logical connections that are independent of the physical hardware. Fabric. The combination of the underlay and the overlay is called the network fabric. It acts as a single programmable entity. 6.3.a. Separation of control plane and data plane. In traditional devices, the brain and the muscles live together. In SDN, we separate them. Data plane, also called the forwarding plane. This is the muscle that physically moves packets from one port to another based on instructions. Control plane. This is the brain that builds the routing tables and makes decisions about where traffic should go. In SDN, the control plane is moved away from the individual device and into the central controller. 6.3.b. Northbound and Southbound APIs. An API is a way for two pieces of software to talk to each other. Southbound API. This is how the controller talks to the network devices like switches and routers. It looks down at the hardware to send configurations. Northbound API. This is how the controller talks to applications or scripts written by the engineer. It looks up to receive instructions from the user or management software. 6.4. AI and machine learning in network operations. Modern networks use artificial intelligence to stay healthy. Predictive AI. This looks at historical data to find patterns. It can warn an engineer that a hardware component is likely to fail next week or that traffic will spike at a specific time. Generative AI. This can help engineers create configurations, write scripts, or explain complex troubleshooting logs in plain language. Machine learning. This allows the network to learn what normal traffic looks like. If it sees something unusual, like a sudden data leak, it can automatically alert the security team. 6.5. Characteristics of REST-based APIs. REST is the most common style of API used in network automation. It works much like a web browser. HTTP verbs. These are the actions you take. GET is used to read data. POST is used to create something new. PUT is used to update existing data, and delete is used to remove it. CRUD. This stands for create, read, update, and delete. It describes the 4 basic functions of any database or API. Authentication. Before you can use an API, you must prove who you are. This is done using things like basic usernames, API keys, or secure tokens. Data encoding. This is how the information is packaged. The most common formats are JSON and XML. 6.6. Configuration management mechanisms. These are tools that help engineers manage the network through code. Ansible. This is an agentless tool that uses simple files called playbooks. It is very popular for automating Cisco devices because you do not need to install extra software on the switches. Terraform. This is primarily used for infrastructure as code. It allows you to define your entire network setup in a file. If you need to build a new data center, Terraform can build it exactly like the last one in minutes. 6.7. Components of JSON encoded data. JSON is the most popular language for network automation because it is easy for humans to read and easy for computers to process. Objects. These are surrounded by curly braces. They contain a collection of data. Key and value pairs. This is how data is written. For example, the key might be hostname and the value would be router1. Arrays. These are surrounded by square brackets. They are used to hold a list of items, such as a list of IP addresses or a list of interface names.